All right, this is Mr. Clausen. I just wanted to go through how to do unit conversions. This isn't meant to replace the information that is in the resources for the course. It's just meant to be a supplement and kind of just have me talk through some of the examples instead of just reading them there. So this is just going to be a real simple we're going to do some of the simpler unit conversions. I shouldn't say it's real simple. It's just going to do some of the simpler ones. We're not going to do the power ones in this video. And we're just going to convert from one unit of measure to another. So that would be our essential question. And so the unit of measure is this concept that we're talking about. And it's something that comes up a lot in chemistry. And so we have it here in the beginning as just a way to kind of get your math brushed up on how to do it. And when we get to further units, we're going to convert, how many grams of chemical A is needed to react with, how many liters of chemical B in order to produce how many, grams of chemical C or molecules of chemical C. And so that's just where it comes up. When we get to those further modules where we have to do that, there will be a refresher. I'll run through how to do problems like this specifically. But what we want to do now is just at least focus on how the process works so that when we get to some of the strange units, the strange unit of measures that we might be dealing with, that you're not as hung up on how to actually do the math and you can focus more on the concept of that unit. So do what you can here on this first one, but it's not worth a lot of stress. Do the best you can, get the passing score, and then move on. So let's just get started here on what we mean by a unit of measure and why it's such an important thing. So I was trying to come up with an example that would kind of work. Please don't judge me too harshly for this one. I just had to do something I could actually draw. So let's say you walk into the kitchen one day and you see 2 plates of donuts. All right, yes, those are meant to be donuts there. And on one of the plates there is 12 donuts. And before you comment to me that I didn't draw 12, there's only 6. It's a picture. It's just meant to represent. I didn't have time to draw all 12. So just imagine that is 12 donuts. All right. And on the other plate it says 2 dozen donuts. All right. And there's another person there or something. They say you can only pick one plate. And for whatever reason, you want to get as many donuts as you can. And so when the person says, take the one that's going to give you the most donuts, you might think at first, because this number 12 here is bigger than this number 2 over here, that you should take the plate that says 12 donuts. Instead of the one that says 2 dozen donuts. But what's different about each of these is they each have a different unit of measure. In the second plate, the unit of measure is a dozen, whereas on the first plate, the unit of measure is just individual donuts. And it turns out, and you probably already know this, you know where I'm going, 1 dozen of something is equal to 12 of that thing, right? And so this plate over here that actually has 2 dozen donuts doesn't just have 12 donuts, it actually has 24 donuts. And so if you were to pick the plate that had the most donuts, you would pick this one right here. And what you just did there was a unit conversion, all right? Like what you probably did in your brain is a unit conversion. It's just we picked a unit that you are used to, which is dozen, which means 12. Okay? And what I just highlighted right there is something that we call a conversion factor. It helps if I actually have the pen on when I do this. Conversion factor. All right. Because you use it when you're trying to convert from one unit to the other. Some other common conversion factors you might know. If I said 1 hour, how many minutes is that? And you would say it's 60 minutes. So if you had to sit and watch a chemistry video for 60 minutes, or you had to sit and watch a chemistry video for 1 hour, they both would be the same length of video. Another one that you might be familiar with is if I said 1 foot, how many inches is this? You would say that is 12 inches. All right, so if you have a piece of paper that's 12 inches long, or you have a piece of paper that's 1 foot long, which one's longer? They would both be the same size. Even though the numbers are different in both these cases. Oops, I tried to hit the highlighter, not the eraser. Even though the numbers are different in both cases, they end up equaling the same thing. Here's another one that maybe you know, maybe you don't. But if I were to say feet to miles, what's the conversion factor we use for that one? You can go ahead and just shout it out at the screen. No, really, just go ahead and shout it out at the screen. Okay, you're not going to do it? Fine. 1 mile is how many feet? Maybe you remember from elementary school. Maybe you don't, and that's okay because it's not something you usually have to have your brain space for. But it's 5,280 feet, which means if you were to walk 5,280 feet or you were to walk 1 mile, you'd walk the same distance in both cases. All right, so these are all examples of what we call conversion factors. And in order to do the problems that like we have down here, you have to know that conversion factor. I tried to pick ones here in the beginning that you're probably familiar with, but maybe not a lot of us know how to convert from kilometers to meters. So if you don't just know it off the top of your head, you're going to have to look it up. And a lot of problems, they'll give you the conversion factor. Or they'll give you a chart, which you can get this chart in our course, and it's got a lot of common conversion factors. So if we take a look there, 1 foot is 12 inches, 1 yard is 3 feet, 1 mile is 1.76 yards, okay? First thing I want you to realize here is this is the U.S. system, the imperial system, and you can see that there's a lot of different numbers to remember. 1 pound is 16 ounces, 1 quart is 2 pints, etc. 1 yard is 3 feet, and this is something that helps you out when you get to the metric system as to why it's a superior system, is every time you go a different step on the metric system, it's just you multiply or divide by 10. But I'm getting ahead of myself. We'll get back to that. Anyway, it's here, and that's what we want to use. So let's take a look at how to do a problem here. This is a sample problem we can do. Max and Elena live 9,277 kilometers apart. How many miles is this? All right, so this is a very standard chemistry science question that you would get. So how do you go about setting this up? The first thing to do is just write down what you start with. So we start with 9,277 kilometers, all right? And eventually, we are going to want to get to how many miles is this. So over on the far side of the page, eventually, we're going to want this to say blank, and then we're going to want the unit to say miles. All right? So we have to fill out the middle part. In order to do this problem, you have to have the conversion factor. And sometimes the problem's given to you, and this time they didn't. So since they didn't, we're going to have to look it up. And so we're going to look on the chart here for one that says miles and kilometers. And if we take a look there, we see that 1 mile is equal to 1.609 kilometers. So let's just remember that as I close this out. And let's write that down over here so we remember. 1 mile is equal to 1.609 kilometers. Now, if you remember what we mean by this, this is the whole idea that if you were to run a mile or you were to run 1.609 kilometers, in which case would you have run further? And the answer is you would have run the same distance either way. They're completely equal to each other. That's what that sign means. And when we do unit conversions, what we do is we take advantage of the fact that when you multiply a number by 1, you're not doing anything to change that number at all. So it's kind of a little bit of math trickery here, but let's take a look at this. If I put a kilometers on the bottom and miles on the top, if we take a look at this, when we multiply this through, there'll be a kilometers on top and a kilometers on the bottom, and so that would cancel out, leaving us with just miles. So I know I'm getting a little advanced. And then we put our numbers here. Miles goes with 1, and kilometers is 1.609. First thing I want you to do is think about this as a fraction. Which side of this fraction, top or bottom, is bigger or smaller? Is 1 mile bigger than 1.609 kilometers? Is 1.69 kilometers bigger than 1 mile? And the answer is no. They're both equal to the same thing. And so whenever you have the same thing on the top as you do on the bottom, that fraction is really just equal to the number 1. And so when we use this idea of the conversion factor inside our unit conversions, we're not doing anything to change the full amount. We're just changing how it is labeled. Okay? So what you would do now is you would just do the math. So to do this the first place, you would get, 9,277 times 1 is just 9,277. And then what you do is you divide that by the 1.6 on the bottom. So I'm going to try and get my calculator up here. There it goes. It's a little big. Good. Didn't have the answer already up there from when I did it before. 9277 divided by 1.609. And if you do that, the number is 5765 point and then a whole bunch of stuff. And so we're going to round to just the nearest whole number. So it would be 5766. All right, 5766. Good. Now, what would the unit be? Now, what I'm going to do is I'll write it out the first time as if I didn't do anything with the cancellations of the units. So what we have on the top then is we've got kilometers times miles. So let's write that in. You would have kilometers times miles. And then underneath it, you would have just kilometers again. Now, if you take a look at that unit, that's a weird unit because it's kilometers times miles divided by kilometers. And this gets to how we set it up in the first place. Because I put kilometers on the bottom to match out with it on the top, those cancel out, giving us just the miles we were looking for in the first place. Okay? So that's how you do a unit conversion. The two big keys that you need to remember is number one, you need a conversion factor. And number two, whatever unit you're trying to cancel out, that needs to go on the bottom because you're starting with the other one on top. Okay, let's try another one dealing with the metric system. All right, here's one. It just says how many meters are in 30 hectometers. Okay, HM, and that stands for hectometers. So let's write down what we did before. Let's write down where we're starting. It says 30 hectometers, and we're going to want to multiply that by something, a conversion factor, and we want that to finally end in meters. Okay, so we need this conversion factor here, and we know that we would put hectometers on the bottom because we want those to cancel out eventually, and we would put meters on the top. The question is, how many meters is equal to how many hectometers, right? Like that's what we're trying to figure out here, these two question marks. So what we can do is if we go back to that conversion factor chart to help us with the metric system, we just got to figure out where hecto is. All right, so if we take a look here, there it is, hecto. It's a lowercase h is what it stands for. And we see that it is multiplied by 100. And what that means is if you were to start at the base unit and you had meters, it would take 100 meters to equal 1 hectometer. If you started at meters and you wanted to go to kilo means 1,000, so it literally means, if you had a kilometer, that literally means 1,000 meters. Let me show you another way that I help remember it, but I just wanted you to see where that came from. This was a mnemonic device my chemistry teacher told me. King Henry died or does make delicious chocolate milk. All right, and these are just the prefixes for kilo, hecta, deca, and then you have your base units of the meter, the gram, or the liter, and then we go deci, centi, and milli. All right. And all this does is it helps us remember how many steps we have to go. So if you take a look here, the metric system is nice because you don't have to remember all those other numbers. Like up here when we were doing this, you have to remember 60. You got to remember 12. You got to remember 5,280. It's 16 ounces in a pound. So there's all those different numbers. Whereas the metric system, the only number you need to remember is 10. And every time you either go up or down on this chart, you're either going to multiply by 10 or you're going to divide by 10 to figure out what it is. So, for example, if we go up to hecta from meters, what we're going to do is, since that's 2 steps, we're going to multiply it by 10 2 times. And 10 times 10 is, good, I'm glad you said it out loud, 10 times 10 is 100. So there are 100 meters in 1 hectometer. You got that? So if you walked 100 meters, it'd be the same as walking 1 hectometer. Let's go ahead and put that in up here for our conversion factor. 100 goes with the M. 1 goes with the hecta. So if we were to run this through, 30 times 100 would be 3,000. And if we did our math right, we should have ended with just meters. So let's double check how the units cancel out. It is hectometers on top, hectometers on the bottom. Those cancel, leaving us with just meters and then there's the answer for that. So hopefully that helps out a little bit on how to do unit conversions. Like I said, the things you need to know is you have to know your conversion factor, and you have to set it up so that the one you're trying to convert from is on the bottom, so it cancels with where you started, and the one you're trying to get to is on the top so that it remains. If you have any questions, please let me know, and I'll talk to you later.